Alright, in this video we're going to learn about what is called concentration. Now this may seem a little weird to you, so let me explain to you what concentration is. If this were to be a glass of tea, and I had tea in this glass, and I like sweet tea, so let's say that all these little dots are sugar molecules that are floating around. They're sweet tea. Now you may think that's pretty concentrated, but if I pour more sugar in there, and I'll make the dots a little darker so that you can see them better on the screen, it's more concentrated. The more sugar I put in there, the more concentrated it is. Why? Because there's more and more sugar inside. Now, if I wanted it to be not so concentrated, I can pour it into a taller glass, and then if I just added more just plain tea, let's say I filled it way up to here, all those molecules would spread out and that would become more dilute. And you've heard those words before. Concentrated and dilute. Concentration deals with how much is dissolved inside of a substance. And typically that substance is going to be water. In this case I'm using tea because that's what we drink a lot. But the same thing would be dissolving into water. The same thing is true for chemicals. The more you dissolve into, the more concentrated it is. The more water you add, the more dilute it becomes. Well, in chemistry, those words weren't good enough. You had to know how concentrated or how dilute something was. So scientists came up with two terms. The first one is called molarity, and the second one is called molality. Now, the words look very close to one another, so you're going to have to be very careful. By definition, molarity, which is capital M, molality is little m, molarity equals moles of solute over liters of solution. Moles of solute over liters of solution. I'm going to come back and define some words here in just a minute. Molality, on the other hand, is moles of solute over kilograms of solvent. I'm going to give you a second to jot these down if you'll pause the video so they can get both of these. And then in just a second I'm going to come back and clarify. Alright, what I want to do real quick is I want to clarify the difference between solute and solvent. Those words are so close to one another. So let's go back to that glass of tea, and here's our sugar dissolved into the tea. Okay, let's talk about solute and solvent. Solute is what is dissolved into solvent or solution. What's being dissolved? That's the main word. Solvent does the dissolving, or sometimes called the dissolving medium. It's what you're dissolving into. Okay? So what's being dissolved? So if you're to have tea and sugar, let's see, solute is dissolved into the solution. So the solute is the sugar, and the solvent is the tea, does the dissolving. The tea dissolves the sugar. And so you can tell the difference between them. Now, many times, another thing that may help you a lot is, especially in science, the most common solvent in the world is water. Okay? Sometimes water is also called the universal, spelled that wrong, universal solvent, because almost everything dissolves into water. Now, does everything dissolve into water? No, you don't get into the shower and come out a midget. But most things, a lot of chemicals dissolve into water. As a matter of fact, anything that you eat, drink, breathe, ingest into your body has to dissolve into water because you're mostly made up of water. So it's the universal solvent. And most chemicals in the laboratory have been dissolved into water. So make sure you know the difference between these two words, solute, solvent. Okay, girls, here's a good example. You have fingernail polish. Fingernail polish. And you have fingernail polish remover. Which is the solute? Which is the solvent? Well, if the solute's what's being dissolved, the solute is the polish. The solvent, thing that's doing the dissolving, is the polish remover. All right? So you just have to think about what's happening, and you can tell the differences between solute and solvent. So why is that important? Well, if molarity equals moles of solute over liters of solution, those words are in the definitions right there. That's why you have to know these. Molality is moles of solute over kilograms solvent. Those are so close to one another, but molarity and molality are very different from one another. Also notice this. There's that magic word again, moles. I told you in this semester we would use moles a lot. Molarity and molality are not very difficult to do. As a matter of fact, their calculations are pretty simple to do. So let's try a couple of them. Let's say that you have a solution contains 1.4 moles of salt in 2.6 liters of solution. What's its molarity? The mathematics here is going to be very simple. You're just plugging into your formula. The very first thing you want to do is write down your formula. Molarity is equal to moles solute over liters solution. All right, let's see what we have in the question. It says the solution contains 1.4 moles of salt in, that means that's dissolving, so this is the solute, salt, 1.4 moles in 2.6 liters. Notice everything's in the right units. So all I have to do is plug it straight into the formula, grab my handy-dandy calculator. So when I take my handy-dandy calculator, 1.4 divided by 2.6, my answer, and usually you just go one decimal place, is 0.5 molar. 0.5 molar. Now notice how I said that, 0.5 molar. That's how it's said. So molarity, 0.5 molar, it's sort of the shorthand way of saying it, but it's not written like that. Just wanted you to see the word. The answer is 0.5 molar. Let's try another one real quick. If you're doing another question, and let's just take these numbers out, and this time, let's say that you have a solution contains 78 grams of salt in 850 milliliters solution. You'll pause the video, give them a chance to write this one down. We'll work it together. All right, let's see what we get. Molarity, start with a formula. Moles solute over liters solution. You'll notice they're all messed up. Moles of solute, that's not moles. Liters, that's not liters. Well, easy fix. Milliliters to liters, back the decimal up 3 spots. So this is 0.850 liters. Got that one. 78 grams, I need moles. So I'm going to have to go off to the side. 78 grams, railroad track, grams to mole. 1 mole. And I have to add up what salt weighs off the chart. Same as always. Sodium's 23. Chlorine 35.5. So that's 58.5 grams. So I take my calculator and I'm going to take 78 divided by 58.5 equals 1.33. Carry a couple of decimals because I'm not at the answer. 1.33 moles. So I'm going to take 1.33 divided by 0.850. Answer 1.6. So it says 1.56. 1 decimal. 1.6 molar. This is about the hardest question I can ask you. Whenever you're doing molarity, you got to know which one's the solute and what's the solution, and look for the words. Things in the question will help you. Make sure you put them in the right units and plug them into the formula. Sometimes they give them to you in the right units, sometimes they don't. Let's see one that's probably the hardest I can give you on molarity, and it looks like this. A 4.6 molar solution contains 110 grams of sugar how many liters of solution? Okay, if you'll pause the video real quick, let them write this down, then we'll do it together. All right, to work this question, start with the formula. Molarity equals moles solute over liters solution. Now you may think, okay, this question's written really weird, and it is, but this is actually how I would work out a problem to make chemicals for you in class. The lab tells me that I need a certain molarity, so it's already telling me this answer. And I know that I have to put 110 grams of sugar. It says how many liters. This is my X. This is what I don't know. 110 grams. Okay, so I have to railroad track. 110 grams of sugar. Now, you're just going to have to trust me on this, or you can add it up on your own. Sugar weighs 342 grams. I only know that because I've used that chemical a lot. You can check it, but it is right. 110 divided by 342 is 0.32 moles. So 0.32 moles. So basically, when I do a lab for you and I have to mix up the chemicals, I've got to figure out how many liters of water I need to pour in there. So this is the math that I actually do to figure out how to do that. Well, this problem looks really weird until I do this. If I'm correct, if I put this over a 1, mathematically, I have 4.6 over 1 is the same as 4.6. Now I have fraction equals fraction. To solve, cross multiply. So I get 4.6 times x, that's these two, equals 0.32. Divide by 4.6. Move that up a little bit so you can see it. Solving for x. So it's 0.32 divided by 4.6. Answer 0.07. I'm going to use the whole number for a second to show you something. 0.06956. What units? Well, my x is here, and it says it's liters. And that would be my answer. Now, how would I do that in the lab? Ask for liters, bang, there's my answer. That's what I'm looking for. If I wanted to know how much that is, if I had to have milliliters, then I could move the decimal 3 places to the right, and I would know that that's 69.5 milliliters also. But since it asks for liters, that's good enough, and you could round it to 0.07 liters as an answer. Solving problems in molarity, pretty simple. You just plug the numbers into the equation. If they don't give you the right unit, like this one wasn't, just railroad track and change it. In this case, putting it over 1 and cross multiplying, I can get the answer to my question. All right, that's how you work molarity problems. Let's look